friends, welcome to my YouTube channel Echo Aftab. In my today's session, we are going to understand a new concept, and that is inverse of a matrix. So before going on into what is inverse of a matrix, let us try to see the basic concept of inverse. What do you mean by inverse? So when we are making use of this word inverse in our daily language, we speak about inverse. It is nothing but that is inverted, or you can say which is a reciprocal. That is what is inverse. For example, if I say the number is 2, then what is inverse of 2? So as you know, in addition, subtraction, multiplication and division, whenever we are transposing the equation, the signs change. So if for example a plus b is equal to c, if I write it, so when I am transposing b on the other side, it becomes a is equal to c minus b. So this is with regard to addition and subtraction. Similarly, there is a rule with regard to multiplication and division. I will come to that later, but right now, as I was telling you, every number, every real number that is there, it is always divided by 1. So it is 2 by 1. So if I want to know what is the inverse of 2 by 1, then the inverse of 2 by 1 will be 1 by 2. So if any number is multiplied by its inverse, what we get is unity. We get the answer as 1. It may be any number. If it is 3, you multiply 3 by its inverse, 1 by 3, then the answer is this 3 and this 3 gets cancelled, and the answer that we get is 1. So this is the first part. So whenever we are multiplying a number with its inverse, we get unity. And the second part is in transposition. If I say ax plus c is equal to d. So in this thing, if I want to bring x on the other side, it becomes a plus c is equal to d by x. So here this multiplication has changed in the transposition and it has become division. So these are the two important things that I had to tell. One is when you multiply the number with its inverse, you get unity, and second one is in transposition the signs change. So with this background, friends, we shall try to understand what inverse is. So here 2 by its inverse is going to give us 1, and similarly when we transpose an equation and isolate a variable, we are inverting the transposed variable. That is, here now I have given you an example. If we are having a into x is equal to z, then what is x? This thing we had seen it when I was speaking about matrices. So normally we had seen 3 matrices. One was a coefficient matrix, the second one was a variable matrix, and the third one was the constant matrix. So in this coefficient matrix, I named it as A, variable matrix I named it as X, and constant matrix I had named it as Z. So what we had written, A multiplied by X is equal to Z. Now the same thing is over here. You can see Ax is equal to Z. Again in my next slides I will be making use of this thing. So it is something like this: 2x plus 1y is equal to 20. So this coefficient matrix becomes 2, 1, variable matrix becomes x and y, and constant becomes 20. So this is what. So now here when you want to find out what is x, so x is equal to this A will be coming on this side. So automatically it will be Z by A, or we can say X is equal to 1 by A into Z, or in other words we can simply say X is equal to A inverse Z. So this is what you can see, 2 multiplied by half is 1. Similarly here you can see when I am bringing the value of the variable A on the other side, so we can say if A is a matrix and if you multiply it with its inverse, we are going to get identical matrix. So this is one important law, A multiplied by its inverse gives us identical matrix. And for this, what is identical matrix? You can refer my video where I have spoken about different types of matrices. So with this brief introduction, what is the concept of inverse, we will start dealing with inverse in matrices. So inverse of a matrix. So here matrices also have reciprocals. This is one thing that we need to keep in mind, as I told in the previous slide. In case of matrices, the reciprocal is called as inverse matrix. In case of matrices, if A is a matrix, it may be a 2 by 2 matrix or a 3 by 3 matrix, then its reciprocal is the inverse of that matrix. Only square matrices with the same number of rows and columns have their inverses. This is one very important condition. You can find inverse of only a square matrix. So only when the matrix is having same number of rows and columns, so this thing should be a square matrix. It may be 2 by 2 matrix, it can be 2 by 2 matrix, or else it can be a 3 by 3 matrix or any higher order matrix. So it should be a square matrix. And lastly, where do we use inverse of a matrix? We use it in our discussion when we are solving linear equations. In other sciences, the use of inverse matrices is tremendous, but for us we will limit it only to understand where we speak about linear equations and unknown variables. To find the value of unknown variables, we use inverse of a matrix. Now friends, what is the formula to calculate inverse of a matrix? So here we are having A inverse is equal to adjoint of A into 1 upon determinant of A. So we can say A inverse is equal to 1 upon determinant of A multiplied by adjoint of A. So here in our previous discussions we have seen what do you mean by determinant of a matrix. We have seen finding out the determinant of a 2 by 2 matrix and how to find out the determinant of a 3 by 3 matrix. Now we need to go into the next part and we will try to understand what do you mean by adjoint of a matrix. So at this particular point, before going on for further in understanding how to solve or how to find out inverse of a matrix, I will take you to the next level, next video, where we will be understanding what do you mean by adjoint of a matrix. So here I will take a break, and in my next session we will try to understand what is adjoint of matrix.